Hi everyone, I am Max Kim, and today we are going to go over AP Calculus BC. In particular, we will be going over a sample FRQ question, which is this one, from the 2023 AP quiz. The graphs of the functions f and g are shown in the figure for 0 to 3. It is known that g of x is equal to 12 over 3 plus x, for x is greater than or equal to 0. The twice differentiable function f, which is not explicitly given, satisfies f of 3 is equal to 2, and the integral of 0 to 3 of f of x dx is equal to 10. So, with that information, we can start part A. Part A is asking us to find the area of the shaded region enclosed by the graphs of f and g. So, it is asking for the area of this region right here. If you take a cross section, say let x equals 1, you can see that the value of the cross section is equal to f of 1 minus g of 1. And in fact, this is true for the entire region from 0 to 3. Therefore, we can conclude that this region's function is equal to f of x minus g of x for 0 to 3. So how do you find the area? That's just the definite integral from 0 to 3 of the function, which we have just determined to be f of x minus g of x dx. We can separate this into two integrals, one for f of x dx minus 0 to 3 of g of x dx. So why did we do this? Because the left integral is given to us right here. It is equal to 10, so this is a lot easier to calculate. This right-hand side, we're not quite as lucky, but as you can see here, the range is 0 to 3. Therefore, since that is greater than or equal to 0, we know that g of x in this region must be equal to 12 over 3 plus x. So we can plug it in directly. Now, this denominator is a little annoying, so we can substitute in u equals 3 plus x with du equals dx. If we do this, then the range of the integral must also change. 0 plus 3 is equal to 3, and 3 plus 3 is equal to 6, with 12 over u du, making sure not to forget the 10 minus at the front. This is equal to 10 minus 12 times the natural log of u from 3 to 6. This is equal to 10 minus 12 times the natural log of 6 minus the natural log of 3, which is equal to 10 minus 12 times the natural log of 2, which is our answer to part A. Part B is asking us to evaluate the improper integral from 0 to infinity of g of x squared dx, or show that the integral diverges. 0 to infinity of g of x squared dx. Once again, the region is 0 to infinity, which is always greater than or equal to 0. Therefore, g of x may as well be equal to 12 over 3 plus x for this region. Plug it in directly, we get 0 to infinity of 12 over 3 plus x squared dx, which is 0 to infinity of 144 over 3 plus x squared dx. We can do the same thing we did on part A. We can let u equals 3 plus x, with du equals dx. If we do this, then the region must change as well once again. 0 plus 3 is equal to 3, infinity plus 3, still infinity, of 144 over u squared du. This is equal to negative 144 over u from 3 to infinity, which is equal to 0 plus 144 over 3, which is equal to 48, which is our answer to part B. Lastly, part C is asking us to if it lets h be the function defined by h of x is equal to x times the derivative of f, to find the value of the integral of 0 to 3 of h of x dx. So find the value of 0 to 3 of h of x dx. If we put in the definition of h of x directly into this equation, we get the integral of 0 to 3 of x times the f prime of x dx. Now, we can instead use integration by parts instead of solving this directly. If we let u equals x and dv equals f prime of x dx, then du is equal to 1 dx, which is just dx, and v is equal to f of x, because when you derivate this, you get f prime of x with the dx afterwards. So if we use integration by parts, we will get that this is equal to uv from 0 to 3 minus the definite integral of 0 to 3 of v du. Plugging it in directly, we get x f of x from 0 to 3 minus 0 to 3 of f of x dx. F of x from 0 to 3, we can plug it in directly. We get 3 times the f of 3 minus 0 times f of 0. This right value, on the other hand, is given to us right here. Minus 10. Now, f of 3 is equal to 2. And 0 times anything is 0. So we get that this is equal to 3 times 2 minus 10, which is equal to negative 4, which is our answer to part C. And we are done. Thank you.